both Voyager spacecrafts carry a greeting, just in case they, any form of life out there comes across them. Each have a 12-inch gold-plated copper disc. It's like a big CD that contains sounds and images selected to portray the diversity of life and culture on Earth. The contents, the images, music, sounds, and greetings were selected for NASA by a committee chaired by Dr. Sagan. They put together 115 images and a variety of sounds. They added musical selections from different cultures and eras and spoken greetings from Earth in 55 different languages. And each record is encased in a protective aluminum jacket, along with a cartridge and a needle and instructions in symbolic language to explain the origin of the spacecraft and show how to play the record if they find it. And both are still actually working and returning data to Earth. I just read the other day that Voyager 1 is expected to last until 2025.
Mm-hmm. Wow, great. Thank you once again for this beautiful and very interesting answer. So another question that I have prepared is, what scientific breakthroughs have we achieved on the International Space Station?
Well, there's a long list, and it would take too long to try to go over them. And not being a scientist myself, I don't even understand some of them. They're studying DNA sequencing and things like that. But I can tell you that they've done a lot to help with medicine and disease. They've found ways to fight Alzheimer's disease, Parkinson's disease, cancer, asthma, heart disease. And some of this is due to the development of new drugs using protein crystals, which form with a much higher quality on the ISS because they're not affected as much by gravity. One of the interesting ones I like is they've had breakthroughs in water purification. The ISS water recovery system purifies and filters the station's water, recovering and recycling 93% of the water the astronauts use in space, including, maybe some people don't know this, including urine and even sweat that they can, get. And that's because it's very expensive to send water to the space that we're anywhere in space. And so they try to recycle as much of it they can, and they just use it over and over and over again. Another very interesting one is that they've recently had some breakthroughs in growing plants in space. There's no up or down, so roots would grow everywhere, and normal water and soil would float away, and seeds would float away too. And also there's no natural day-night cycle for light. So seeds are glued in place in what they call plant pillows that deliver fertilizer and water, and LED lights are used to encourage the shoots to grow in the right direction, like sunlight would normally do on Earth.
Yeah, thank you. That's really, really interesting and amazing. So yes, another question. Mute someone. Yeah. So the next question is, what is NASA planning to achieve with Artemis mission?
So it's interesting. Most of you probably know that Artemis is the Greek goddess of the moon and the twin sister of Apollo. Yes. And his main goal is landing the first woman and the next man on the moon. Longer term objectives include establishing an expedition team and a sustainable presence on the moon, and eventually using it to help send humans to Mars. There's several components to Artemis. What they call a lunar orbital platform or gateway that would be like a small space station that just continually orbits the moon instead of the ISS that orbits the Earth. And NASA's getting close to finishing development of a huge new rocket, the Space SLS, the Space Launch System, that's even more powerful and larger than the Saturn V rocket that took our astronauts to the moon. And so the idea there is that 4-person crews could fly to the gateway on the Orion vehicle that NASA is also developing, and live for 30 to 90 days on the gateway, and they could make trips down to the moon's surface and then come back to the gateway. So they could just be going back and forth from the gateway to the lunar surface rather than from the Earth to the lunar surface. And there's also a push for an enlarged role among private aerospace firms. They're trying to develop a lunar economy and get more private industry involved. NASA's already awarded contracts to several private firms to send spacecraft to the robotic spacecraft to the moon to collect data and conduct research there. Some are thinking about mining lunar resources such as water, which of course can be split into their hydrogen and oxygen molecules and converted into rocket fuel.
Oh, that's really, really great, and really looking forward to seeing it happen. So
yeah, me too.
Yes, and the next question is how can students participate in space science programs?
Well, so that's a good question too, and you know, it depends on, to some extent, on where you live, right? There are some lots of programs that are available only to United States students, because you have to you know, be local to participate. But having said that, there are also NASA does, in my opinion, a great job with information on the internet and social media, and so there are a lot of activities, student activities, and segregated into, you know, younger and middle-aged students and older, even college and university students, and with you know, articles and posters and videos and experiments that you can choose to do. And in fact, I'd be happy. I do have. It's fairly easy to find them just by Googling them, but I have a couple of websites that I can put in the chat that will take you directly to, yeah, I'll put them there as soon as we're finished speaking. So anyway, no matter where you live, you have to speak English, of course, to understand the sites, I believe, but lots and lots of activities, STEM activities, you know, mostly science, for students of all ages, available on NASA websites.
Thank you very much for this great responses, Mr. Herb, and we're really looking forward to further cooperation with you, hopefully learning more from you in the future. So yeah, really, thank you very much.
You're welcome, and I will post those links that I mentioned in the chat right now.
Please do. It will be really amazing. So now a little announcements to everyone. People feel free to submit your questions in the Zoom chat. So later on at the end of this meeting, we're going to have a Q&A time. So please feel free to submit those questions. Now that we heard a lot of great things about human accomplishments in space exploration, let us dive into a deeper discussion about our heroes, the explorers of new worlds, the astronauts. And who would be a better person to ask than Carlo Vizzi? Since 2018, he is working as an ALTEC contractor at the ESA European Space Astronaut Centre as an astronaut instructor, and is still involved in VR, AR, and XR activities, in particular in the field of astronaut training and life in space. Well, welcome, Carlo. It's an honor to meet you and really great to have you here.
Hi, everyone. Thanks for having me. It's a pleasure also for me.
Thank you for finding the time to join us. So I have prepared a few questions here as well. So the first question, which probably, since most of our spectators are students, the question which they will have is, what education do you need to become an astronaut?
That's pretty simple, I would say. So to become an astronaut, the first thing is to get an education, and you have actually a few fields where you can start your career from. Of course, you need minimum a master degree or a PhD, and that could be into engineering, computer sciences, mathematics, physics, or any other kind of natural sciences like physical sciences or earth, atmosphere, ocean science, biology, all these kind of, let's say, technical, but also kind of more toward nature career at university. It's also very welcome a career into medicine. So any kind of doctor, since you are targeting the moon, we're targeting to go even farther, we will need doctors. So another very interesting career can be also the medical side. And of course, any kind of test pilot, test engineer, or any other kind of experimental test pilot school. So those are, I would say, the main areas for applying to be an astronaut. At least I'm talking about ESA now. So from Europe side, I'm pretty sure NASA should be the same, but that's strictly now for ESA. And then, of course, you need to have some kind of experience already on the job with some kind of responsibilities. And since we're talking about an international environment, you need to be very fluent in English. And if you know any other language, it's very welcome. It's not mandatory, but if you know any other language, it's of course a plus.
Thank you very much, Carlo. And are there any particular activities that someone must do in order to become an astronaut, like besides the education?
Sorry, I think you should repeat your question because my headset is disconnected.
Yeah, so I'll repeat it. It's no problem. So besides the education, are there any particular activities that one should do to become an astronaut at ESA?
I would say yes, of course. First of all, I would say just do anything that you like, anything that you might enjoy, anything that you give you some really interesting or something that you can really enjoy as a personal background. And then you start from that and you really create your own career, your own interest out of that. And then if we want to go more specifically into the kind of activity that you might need or that can help you in the application for becoming an astronaut, I would say everything that is like experience on the field. And by field, we usually define this kind of environment that are pretty hostile, like, I don't know, this kind of analog in the jungle or in the desert, in the pole, in the Alpine, on the mountains or somewhere else. So all these kind of activities that are a bit, you know, not really office job or not really job experience. Then also any other kind of experience in laboratory, control center, or again, non-office work environments where you can really build your practical skills as well, where you can really apply some real piece of experience and anything that again will require you to develop some kind of responsibility. If you think to become, you will become an astronaut, then you will have to go through this kind of really challenging environment. You might take decision, you might be working, you will be working in team, and you need to, let's say, work in a certain way, and also in a very closed and strict environment, like be the station or like be another spaceship when you will be traveling to the moon or Mars. So there are a lot of experience you can do in this kind of analog environment, how they call them.
Well, that's great. Thank you again, Carlo. So the next question is, it's regarding microgravity, and the question is like, what effects does microgravity have on astronauts' organisms, and what they do in order to solve and prevent this effects?
of being an astronaut is extremely demanding for the body, for the mind. You have to be long for a long period away from your parent, from your family, from Earth. So you'll be working in this kind of very different environment, and also your body will be subject to this kind of different environment. So our body is born and is used to gravity, to 1G condition. So we are used to stay upright, we're using to walk because something is pushing on the floor. But when you are in microgravity, all this doesn't exist. So you will be free floating, and also for your body, it's a completely different story. So your body has to readapt, has to relearn all the things that it's used to do, it's used to perceive. So of course, at the moment, we already know some kind of effect of gravity on the body. For example, we lose muscle. Since we're not training, we're not used to use our muscle while we are on the station. While we are in microgravity, our muscle will get smaller. Same goes for the bones. The bones will get smaller and smaller, and with a certain range, but still it will affect also the bones. And to contrast this kind of things, so we are already, first of all, taking into account the health of the astronauts. So they have to practice exercise 2 hours per day so that their muscle and the bone will be still in a good shape when they're back. And also with nutrition, the same way in the same way when you go to the gym or you have your target to lose weight or to gain muscle or to do anything else, astronaut will have to set this kind of target, and with nutrition trying to compensate the effect of microgravity or this kind of effect on the body. And at the same time, we are constantly studying what kind of effect with physiological experiment or any kind of experiment, we are always studying what kind of effect microgravity has in the body. And then this kind of result can be matched also on understudy on Earth. So maybe you can understand how the body works better in space since you don't have the gravity constraint, and then reapply what you learn on a patient on Earth, for example.
That's really, really interesting. Thank you, Carlo. So moving on to the next question is, like, how does the daily routine, the like daily exercise plan of astronauts look like? Like, how many hours do they have to train every day, or what's their routine?
By training, you mean training on ground before they go to space, right?
And how many hours do they have to work, and what kind of training exercises do they undertake, and like what do they do?
That depends. Usually after an astronaut is selected, they go through 3 different cycle of training. They start with the basic training, that it's a training that takes place for around 1 year roughly. And they start to learn the basic of being an astronaut. So usually, as we say, an astronaut, when he's selected, is coming from different background. It could be a pilot, it could be an engineer. So they don't know everything about space, probably don't know anything about space. So they start this kind of process to learn about the International Space Station in this very moment, about the international partner, how it works, what does it require to be an astronaut. So once the basic training is done, they start some kind of pre-assignment training, and they go through a very, let's say, not really specific, but somehow it's more specific to a mission training. So they start learning about a bit more detailed things about the International Space Station, about the modules that compose the International Space Station, how to operate different kind of tools and machine inside the station. And then at the very end, once they are assigned to a mission, once they know that they're going to fly in a couple of years from now, they start with what it's called increment training. So they start to train on the specific activities that they will have to perform. And that means training on the experiment that they will have to execute in the station. They will need to learn which kind of vehicle they will use to get to the station. So that needs also some kind of training. There needs to be physically trained. You need to be fit when you go on the station. You need to get there with a certain physical condition regarding muscle, bones, and everything else. There are a lot of steps, or there are several steps for the training, and then the number of hours, of course, it changes. And every astronaut is supposed to train or somehow get some training in every facility from the international partner. So as you know, International Space Station, it's an international collaboration in between NASA, ESA, and then we have the Russian agency, the Canadian agency, and the Japanese agency. So the astronauts have to fly in all these facilities and get training in the specific modules of the International Space Station.
Thank you, Carlo. So that's really a lot of work to become an astronaut and to train, a lot of training. And the next question is like, how does the astronaut application process at ESA look like, and where can people apply?
So all this information that I'm giving you can be found on the ESA website in the career section. And I'm not involved in the astronaut selection at all. I'm training astronauts. But now in this very moment, we have the new application for astronauts ongoing, and I think they will still be open until June the 18th. So if you go on the website, check the requirements, and if you're still in the right range, just apply. So for the first part of the application, what you need is just your curriculum, your CV, a motivation letter that you write yourself, and a few certificates for your health and some other, let's say, yeah, certification to assess that you're okay for this kind of career. After that, they are waiting for a lot of applications at the moment, considering that last astronaut selection was in 2008. So now it's been already a few years since the last selection. After that, there will be the first screening, and after the first screening, there will be, if you go through the first screening, then you will start with some tests, and then medical test, the physical test, and at the end there will be some kind of interview with the panel, and then at the end a final interview. So there are a few steps, and it's a very challenging process, and it will last for more than 1 year.
Thank you very much, Carlo, once again for finding the time to join us today and for all your great responses. And yeah, really looking forward to further cooperation with you as well, of course.
Yeah.
Thank you. So
You're welcome.
now,
Thank you.
Moving on. So in the 20th century, American astronomer Edwin Hubble, among many other things, discovered that the universe extends beyond our galaxy, the Milky Way. There is even an orbital telescope, which you can see right now, which is named after him, which was launched in the 1990 and is still operational and has provided us with the dazzling array of deep space pictures, unveiling that the space is not only overwhelmingly vast, but also is mind-blowingly appealing to the human eye. Now, the James Webb Telescope, which is a NASA, ESA, and CSA space telescope, a joint mission, and is planned to succeed Hubble telescope at NASA's flagship astrophysics mission. And the telescope will look for the first galaxies that formed in the early universe, and it will also peer through dusty clouds to see stars forming planetary systems. But how large exactly is the universe? And is there an edge to it or boundary to it, or is it infinite? And we have just the perfect person to ask that too present here today. So Janet Ivey is committed to enriching the lives of children through education and programming. With over 17 years in media, Ivey has captivated Nashville and beyond with her work, and she has received 12 regional Emmys and 5 Gracie Allen Awards for her work. Buzz Aldrin has chosen Janet to be one of his ShareScience Education Ambassadors for his ShareScience Foundation because of her enthusiasm and dedication for science education. Thank you, Janet. It's an honor to meet you, and really appreciated that you found the time to join us today.
Oh, you guys are so kind. I'm enjoying all the questions and all of the commentators. Herb and I have been friends for a long time, and fantastic to hear from an astronaut. That's always exciting.
Thank you. Thank you. So now moving on to the first question is, how was the solar system created, and why is the universe expanding?
You know, this is one of the questions that we're all still kind of, thinking and processing, right? So I love it as, you know, we've been talking a lot about astronomers, but let's talk a little bit about cosmology.
Mhm.
And I heard a dear cosmologist say that we always think of that first moment as the Big Bang. But a cosmologist out of England once said, what if we think about it as being that first big breath?
Whoa.
And then everything began, and these nurseries, I mean, it's like fascinating to think about, right? We know, and you can even the whole concept of time sort of originates with that first moment, because we know nothing of before that moment when it all began. So we look at that thing of 13.9 to 14.5 billion years ago. And then here we are in our own little Milky Way galaxy. We can, you know, date our existence on this outer spiral arm of the Milky Way at 4.5 billion years. And so again, when we think about how everything was formed, it really does sort of like capture our imagination. And so when we also think about it, if I were, and I meant to do this, and I don't think I have it laying around here, if I were to blow up a balloon and I were to just make little dots, I'd go, okay, here's our universe with all of the, you know, here's our little galaxy with its 200 to 300 billion stars inside of it. And you're going, but, you know, is there a beginning or end to the universe? Is there something else? You know, it's really hard to imagine that, you know, and how it's even hard to imagine how big our universe is. And when we think about it, astronomers estimate that there could be around 100 billion galaxies. And it's like, you know, like we think we're pretty special in our little outer spiral arm, but imagine if there's 100 billion, if there's, you know, 99 billion 99, 900, and you know, all those kind of billion galaxies and us, there must be life out there, right? And what I think is important to remember is that much of the universe is actually empty. Space, I mean, a lot of dark matter and dark energy, that's that stuff that we can't see and we can't really yet explain. I mean, ordinary matter only makes up about 4 to 5% of the universe. And then we talk about, and you go, well, Janet, what is dark matter? And scientists think stars and planets wouldn't move as they do if they're just the space was empty. So we don't yet have that ability to measure dark matter. And dark matter is thought to make up between 25 to 28% of the universe. So you're like, all right, then what's the rest of the stuff? And you're like, oh, it's dark energy. And dark energy is how scientists refer to the force that's thought to be behind the expansion of the universe. And so dark energy is thought to make up between about 67 to 70% of the universe. So if dark energy is that force, it's like da da da, we sound like we're talking about Star Wars, right? Is the force that is thought to be behind everything expanding. And again, like I said, if you ever want to do this with children, just take a balloon and, you know, blow it up. So maybe it's about the size of the, you know, you could dot it with a magic marker, make it about the size of an orange, clip it with a balloon clip, and then, you know, you can remove the clip and keep blowing up the balloon. And what happens to those dots? Well, the more that you blow that air into it, it's the distance between those dots gets wider and wider. And so we know those are the effects of that dark energy and expansion happening. And again, in many ways, it's like we're continuing to drift apart. So while I and many others are still scratching our heads and going, why does it expand? I think it's just important to know that for all of you students out there, hey, why do you guys figure out what exactly is dark matter? Somebody else out there, or several somebodies out there, figure out what dark energy is, and then we're going to get a clearer example of that. But I think the most exciting thing about this proposition that we live in this ever expanding universe is that we have been given these amazing brains and the gift of being able to participate in understanding and creating the math and understanding and discovering why all of this is happening. Again, the expansion is there and we know it. We have identified, we're getting closer and closer to identifying what dark matter and dark energy are, but maybe some of you guys will end up finishing that out and helping us understand more.
Well, that's a great answer and really, really awesome comparisons to things. The really nice way to put it and explain it. Thank you very much. And the next question is, what are black holes and how do they form?
Oh my gosh, is that not the most interesting thing ever?
That
Let's
is.
all remember that a black hole, and there's a great Netflix documentary that I want to point you towards, and it's scientists working and physicists working right alongside Stephen Hawking before he went on his next journey somewhere in the universe. So I highly recommend that. But a black hole is a region in space where the pulling force of gravity is so strong that light is not able to escape. And that strong gravity occurs because matter has been pressed. I mean, think about it, compressed in such a tiny, tiny place. And that compression can take place at the end of a star's life. And some black holes we know of are a result of dying stars. But because no light can escape, black holes are pretty much invisible. But the way that we do it with space telescopes, we use special instruments that can help us find those black holes, and they observe the behavior of materials and stars around them, and then we're able to recognize that. But I think, and I was just teaching some children about this, it's like black holes come in a range of sizes. They're basically three main types. Basically, the black hole's mass and size determine what kind it is. So the smallest ones are known as primordial black holes, and scientists believe this type of black hole is about get this, as small as a single atom, but with the mass of a large mountain. Yes, a black hole as small as a single atom, but with the mass of a large mountain. And maybe the most common type of medium-sized black holes we call those stellar black holes. And the mass of a stellar black hole can be up to 20 times greater than the mass of the sun and could fit inside a ball with a diameter of about 10 miles. Dozens of stellar mass black holes may exist within our Milky Way galaxy. Now, the largest black holes are called supermassive, and these black holes have masses greater, get this, than 1 million suns combined and would fit inside a ball with a diameter about the size of our solar system. I mean, crazy, right? And scientific evidence suggests that every large galaxy, and we talked about there might be 100 billion of those galaxies out there, at the very center that there's science suggests that it contains a supermassive black hole right there at the center. And our black hole that is at the center of the Milky Way galaxy is called Sagittarius A, and it has a mass that is equal to about 4 million suns and would fit inside a ball with a diameter about the size of the sun. So again, if it's got the mass equal to 4 million suns, again, it's hard to wrap your minds around that. But, you know, primordial black holes were thought to have formed in the early universe. Stellar black holes form when the very center of a very massive star collapses in upon itself. And scientists think that supermassive black holes formed about the same time as the galaxy they are in. So we know the Milky Way galaxy is about 4.5 million years ago. So that was about the time that Sagittarius A formed. Again, because no light escapes, it's like, you know, could a black hole ever destroy Earth? I mean, they don't wander around the universe randomly swallowing up worlds. I mean, they follow the laws of gravity, just like other objects in space. And, you know, NASA's been studying black holes using the Chandra X-ray Observatory, the SWIFT satellite, and the Fermi Gamma Ray Space Telescope. But if you want to learn more from the physicists who are really doing the work, I highly want to point you to that Netflix documentary.
Wow, that's really mind blowing. I mean, the scale of the mass and everything that's really mind blowing. So another really interesting subject and question that I have is, how do the scientists detect exoplanets?
Oh, Kepler's been doing that for a long time. In fact, I'm going to post and direct you toward the Kepler telescope. They're doing beautiful work. But let's talk about 5 ways that you can find a planet. First, you're going to look for radial velocity. And I know I'm talking to some people who love science, but let's break it down to some very simplistic language. We start to look for a wobble. It's much like Clyde Tombaugh discovered Pluto. If you don't know the story of Clyde Tombaugh, I love this story. He was 18 years old, wanting to go and study and be an astronomer. And right before he's to go off to college, his family's farm is destroyed by basically a hailstorm, so rendering his chances of going to college impossible. But he doesn't give up. He's like, well, I think I'll just build myself my very own telescope. So he built his own telescope out of old farm machine parts and the headlights off his dad's old Buick. He started examining the night sky, drawing pictures of it, sending it to the Lowell Observatory, and they finally go, this kid's talented. So they hire him without a college education. Percival Lowell gave him what he believed. They knew there was something wobbly. So this is how 5 ways we find a planet, and how 5 ways that we find even an exoplanet is we're looking for something that wobbles. Remember, stars are fixed points. The only reason that we see them as twinkling is because of our amazing atmosphere. There's no twinkling above our atmosphere. But again, we're looking for that wobble. Well, Percival Lowell gave Clyde Tombaugh the wrong coordinates, but 10 months later, he kept noticing this odd wobble with this blink comparator. I mean, one little blink at a time over 10 months, but yet he discovers Pluto, which went on to become a dwarf planet, of course. So in much the same way, when we are looking for exoplanets, much like the TRAPPIST system and things like that, we're looking for a wobble. And over 850 planets have been discovered that way. We're also looking for transit. So we're searching for shadows. So every time that would come around and you got a telescope on it, you're going to see that shadow pass. And as you begin to see that shadow pass often enough, you're like, I think that is a planet orbiting its star, its sun, and over 3,336 planets have been discovered using the transit method. Now, another way that we find them, this takes a lot more time and absolute certainty of where you're looking, but direct imaging. And yeah, that's just taking pictures. Directly imaging is like, yep, that's a planet. Over 53 planets have been discovered that way. You've also got gravitational microlensing, and basically you're using light in a gravity lens, and over 108 planets have been discovered that way. And, again, when you begin to look at this last one, it's like astrometry. And you're basically looking for these minuscule, and I'm talking micro movements, and we've discovered one planet that way. So again, most planets are found via the transit method, and that was the case for the TRAPPIST system. In fact, the word TRAPPIST actually stands for the ground-based transiting planets in planetesimals small telescope. NASA loves its acronyms. So yeah, it's like, I will post a link for ways to find exoplanets. And there's lots of citizen science out there where a dad and his daughter found a whole system of exoplanets. So become a citizen science and scientist and start looking for opportunities to check out the night sky.
Oh, thank you very much, Janet, for finding the time to join us once again. Really, really appreciate it. So now everyone can see this is the Great Wall of Bos. It is the largest structure in the universe that we have ever discovered. It is like over 1 billion light years across, larger than anything else identified so far. And now has come the time for which you have all been waiting for. So, and it's the Q&A time. And now I'm sure a lot of you have already submitted a lot of questions. And okay, so I have the questions here. Let's see what questions. Of course, we can't cover all of the questions, but I have some of those highlighted. So the one question is, what is your involvement in Mars exploration programs? And why is it so important to explore Mars? So that's a question for Janet, I believe.
You know, I put in the chat earlier that Gene Roddenberry has this great quote where he says, "We are on a journey to keep an appointment with whatever we are." He was the writer of Star Trek. And so for me, humans on Mars means, I mean, you opened up with it yourself, my dear. You said that exploration is in our DNA. It's down in our bones. We want to explore. I mean, the only place I think on Earth that maybe remains to be explored more in-depthly are our oceans, you know, but we've done it. And so to move out beyond, I think there's a couple of questions. Don't we all, in that world of astrobiology, aren't we all really going, are we connected? I mean, again, when we think about it, that we are connected to one another biologically, to the Earth chemically, and to the universe atomically, that starts to feel like, whoa, you know, you kind of get some chill bumps there and go, we are very connected. So if we go to Mars and we find, you know, and that's what Perseverance is doing, right? It's looking for life or microbial life or fossilized microbial life. Then our question becomes, I mean, yeah, it's another 50 million miles away from the sun, but why didn't it expand? Why didn't life go from those microbes to something like we have and we know on Earth? And then that discovery of phosphine in the clouds of Venus. Phosphine is a toxin that's released by microorganisms. What's going on? Does life exist in that hot environment? So for me, humans going to Mars means we can do things in hours that it takes weeks for a rover to do. It means that our species is moving outward and potentially inhabiting other worlds. And it means the survival of our species. One day when that sun gets so big, maybe we will have found ourselves all the way to the moon of Titan, you know, Saturn's moon Titan. But to me, it's part of us. It's like we're destined to explore, destined to conquer things that are seemingly impossible, and destined to understand more about this precious thing we call life, this little blue ball of Earth, and maybe perhaps points us to a greater understanding of what an amazing ecosystem, and will treat our world better. And even more importantly, maybe it points towards how we all are truly connected and we start being better crewmates here on Spaceship Earth.
Thank you. That's really great. So now comes another question. What was one of the hardest missions that this generation of astronauts has completed? And this is a question for Herb, I think. And Carlo as well, if he have, of course. So.
Well, so the answer to that probably depends on who you ask. I'm aware of lots of missions that were difficult. One that comes to mind, I don't know if it's the best answer, but the final mission, the Space Shuttle mission to repair the Hubble Space Telescope, you know, it was a completely different orbit than most of the shuttle flights, and certainly the ones to the ISS, which is about 250 miles high. The Hubble Space Telescope is about 300 miles. So it had to go to a different orbit. And the one thing that I think of, besides the fact that it had to be very delicate with the instruments, you know, the worst thing would have been to somehow, as they were working on repairing it, to damage it. So the scientists were constantly telling the astronauts, you know, be careful, be careful. And this one story comes to mind. Mike Massimino was one of the astronauts who worked on that last Hubble Space Telescope repair mission. And he got to a point at one time when he needed to access the inside of the telescope, and he was trying to to take off a screw or something or a plate, and there was a handle in the way, and he was having a really hard time. It apparently wasn't working the way it was supposed to, and so he was, working and working, and it just wasn't going to come off. And so conversations with the mission control team, they finally decided, well, I guess the only thing you can do is just try to literally rip it off. And he was, kind of hesitant to do that. If you think about being told to be careful, and now he's gonna grab this handle that's in the way and literally rip it off. And he did, and it worked. So I can imagine how happy he was that he didn't destroy the telescope when he ripped that handle off. And so anyway, that's one of the reasons that I think that was one of the most difficult missions.
Oh, that's a great story. So, Carlo, now the same question to you. What do you think is the best thing that the generation of astronauts has ever accomplished?
Yeah, I think it's really hard to answer. Of course, what Arab described was a really good example. And it's really hard to say which one is the hardest, considering that every mission is basically adding on top of the previous mission. There is no really way to compare probably every mission to each other. Like we've been going through the space race in the 60s at the end of when we first went to the moon. That really gave to everyone this kind of sparkle towards space. And after that, we've been building over and over and over until now we're going again to the moon, but with a different objective. So I think the hardest mission, I would say, is probably yet to come. And it will probably become in the next 10 years or even more if we are looking at Mars. But still, I think we are going to witness a very interesting time for space exploration when we will create, or we will really have our habitats on the moon, and then we'll start thinking how to really get to Mars with astronauts, with human beings. That would have been probably the hardest. So far, we're still building on top the previous mission with different moments during each mission. Each mission has been experiencing some really hard time, moment, decision, and so on. But still, I think we still have to see something even harder than what we have been witnessing so far.
Thank you, Carlo. Thank you. Really, really interesting and a good way to look at it. So another question that I just found is, could you explain how the universe can be infinite if it had a beginning finite amount of time ago? That's the question to Janet, I believe.
Oh, if I could answer that, my friends, I would, I might already be living on another planet. I think, here's what I think. When we think about that, it really becomes even more than just a scientific question. It's a philosophy question. It's a spiritual question. It's a personal question. I think in that infinite way, it's like, as we were talking about the masses of those black holes, again, hard to even wrap our minds around it. It's hard for me to wrap my mind around that there are 100 billion galaxies, even though I've heard, lecture after lecture and read that is true. And so I think for me, I can't answer that. And I think it remains, again, another one of those unanswerable things, right? In that infinite world, are we talking actually infinite, or are we talking kind of like metaphorically? I like to think that it's like, it's like, will it expand so much that it finally wraps around on itself? It's a beautiful, beautiful thought equation, and one I think that takes us to those other realms of consciousness nearly as we ponder what that means, right? What does it mean for us if it is indeed infinite? And so how I wish I could give you some scholarly, brilliantly stated answer. I think that I would return that to you and go, what does it do for you, or how does it affect you to think about it as a personal mechanism, as a spiritual mechanism of an infinite universe. That's where I tend to sit with it sometimes. And again, in our lifetime, some of you may very well be answering these questions. How I wish I knew, my friend.
Well, I hope we will. I found another interesting question. And how does analytical chemistry get used in studying bodies found in our solar system, since they do have an interesting composition, and how does that benefit today's world of astronomy? That's a question for everyone, like whoever would like to answer that. So it was quite a long question, and I'll make sure to repeat it. So how does analytical chemistry get used in studying bodies found in our solar system, since they do have an interesting composition, and how does that benefit today's world of astronomy?
I put a bit of an answer just in the chat. It's like when we talk about analytical chemistry or cosmochemistry, again, we're studying those chemical compositions. Once we know, I mean, when you think about the super cam on Perseverance, I mean, it's got lasers, and it's like as soon as it pulverizes the rock, it can then analyze what those chemicals are. What that is going to tell us is that, are these dangerous to humans? What is this like? Is this like anything we know of on Earth? So I believe it's like in the world of analytical chemistry, the more how it serves our exploration, and especially as part of our solar system, is that, again, it just continues to peel those layers off that onion to say, I mean, again, finding phosphine, because we know it's a toxin for microorganisms. Why is that in the clouds of Venus? We know it's like, 860 degrees Fahrenheit on the planet. It's surrounded by dense layers of clouds, that were created by the release of sulfur dioxide gas from all of the volcanoes on Venus. What do you mean? And so then we go to the very deepest parts of our own oceans, where we think life shouldn't exist at all, but we find these weird organisms living near these heat vents at the bottoms of our oceans. So for me, that analytical chemistry or cosmochemistry just, again, tells us we are all in this thing together. We are all related chemically, biologically, and atomically.
Oh, that's really amazing. So thank you again, Herb, Carlo, and Janet, for joining us today, finding the time, and for all the great questions and stories. It was really interesting. So thank you, and looking forward to further cooperation. And I guess that's it for today, guys. And also thanks for everyone for joining in and listening to us. And first of all, thank you for your interest in astronomy, in space industry, and all of this, the understanding of the universe. And I really hope that some questions which are not yet answered by anyone will be answered, hopefully by someone, probably even in this Zoom call. So yeah, so thank you, everyone. There's gonna be a lot of more events upcoming from Mars Society Georgia. Just keep following our Facebook page, our social media, and you're gonna find a lot of great information and a lot of great opportunities to possibly even participate yourself. So once again, thank you, everyone, and that's gonna be it for today.
Live long and prosper,
Bye-bye.
everybody. Bye, guys.
Bye-bye.
Bye.
Thank you.
Goodbye.
Goodbye.
Goodbye.